Hello guys, let us take another set of GET questions from amplitude modulation from previous year papers. So the question is in an amplitude modulated signal the peak voltage varies from 2 volt to 10 volt. Okay, so we have to identify or find out what is the total power in amplitude modulation. That was the main question. Okay, I have added some more questions like what is my carrier signal power and what is my power in sidebands, as well as what is the efficiency of amplitude modulation. Alright, so these are the three questions that is additional. So what do we need? The amplitude modulation signal is actually varying from 2 volt to 10 volt. So I have already taught you this is the envelope of amplitude modulation signal, something like this. Okay, so you can see this is the maximum, like a max, and this is the minimum. Okay, that is a min. And as you can see that a max is equal to 10 volt, here it is written, and a min is equal to 2 volt. So I have given you a like a relation for maximum and minimum. So if you want, you can derive directly AC into 1 plus mu, and a min is AC into 1 minus mu. So from here you can find out what is your carrier signal amplitude and what is your modulation index. Alright, so I have done it for you that a max is 10 volt, a minimum is 2 volt, and mu is a max minus a min by a max plus a min. If you solve this particular relation, you can subtract it. So a max minus a min by 2 AC will come, and AC comes as a max plus a min by 2. Okay, so from here mu is equal to a max minus a min by a max plus a min, that is going to come up as 10 minus 2 divided by 10 plus 2, that is going to come up as 8 by 12, that is 2 by 3, that is 0.66. Similarly, I can find out what is my carrier signal. So carrier signal amplitude will be a max plus a min by 2, that is 6 volt. Okay, now the question is that is being asked is carrier signal power. So carrier amplitude we know. What is the carrier signal power? AC square by 2, that is going to be coming up as 6 square by 2, that is 36 by 2, that is 18 watt. Okay, so this is as simple as that. Now we have to find out what is total power of amplitude signal as well. So total power, you know formula, PC into 1 plus mu square by 2. This is another method that you can utilize. Otherwise you can find out PC into mu square by 2, that is sideband power plus the carrier power. So I have done it for you here. The sideband power is PC into mu square by 2. So PC was how much? This was 18. Okay, just now I told you PC was 18 watt, right? Divided by mu square. Mu square is 2 by 3 ka square, that is 4 by 9, and divided by 2. Okay, so mu was actually 2 by 3, so mu square is 4 by 9, that is so if you cut this, 9 to the 18, 2 to the 4, so that is 4 watt. So 4 watt is the power that is available in your sidebands. Okay, so what is your total power? The total power can be carrier power plus sideband power, that is 18 plus 4, that is 22 watt. Okay, or otherwise you can utilize from PT's like a formula, that is PC is 18 into 1 plus mu square by 2, that is 4 by 9 into 2. Okay, so 2 2s are 9, so it is going to be 18 into 9 plus 2, that is 11 by 9. Okay, so 9 2s are, so 11 2s are 22 watt. So any of these two formulas you can utilize. It is very simple to understand, you don't have to memorize. Why? Because the sum of carrier power plus sideband power is the total power in amplitude modulation. Okay, the same concept had been utilized to derive this particular formula, PC into 1 plus mu square by 2 as well. Okay, now what is the efficiency? Efficiency was also asked. The last part is the efficiency of the AM signal. So the efficiency of AM signal will be sideband power by total power, that is going to come up as sideband power is 4 by 22, that is 2 by 11, that is 0.1818, that is 18.11%. Okay, or otherwise you have the formula in terms of modulation index for the efficiency calculation of AM signal. So what is your AM efficiency? So mu square by 2 plus mu square. Why it is coming mu square by 2 plus mu square? You guys know already, right? PSB by PT. So PSB was how much? PC into mu square by 2. This is PSB by PT. So PSB was PC into mu square by 2 divided by PT. PT is PC into 1 plus mu square by 2. Okay, so this if you try to solve, so you are going to get PC got cancelled, by 2 will get cancelled, so it will become mu square, by this 2 will come up, so 2 plus mu square. Okay, so this is your efficiency. So in GATE there is valid reason for you to derive the formula as well as proceed. Let's take another question. So the question is in an AM signal we have carrier signal as 20 cos 4 pi into 10 to power 60. Okay, so carrier signal is given and we have two message signals. I have written the question in notation form. Okay, so the question in that first modulation, first signal message is 10 kilohertz and another signal, another message signal frequency is 20 kilohertz. Okay, now the it has gone through two modulation indexes. First one is mu1, that is 0.6, and mu2 is 0.8. We have to identify all the parameters. Basically the question is always in your gate, what is the total power of amplitude modulation signal? Okay, so that is very simple, but we have to do more calculations. So we will start with calculating the bandwidth, signal power, then total power in sideband signal, as well as upper sideband and lower sideband powers, and at last we will find out what is the efficiency. So this is a complete set of questions which will make sure that you have a complete understanding of amplitude modulation. Okay, so what is the bandwidth? So I have told you bandwidth is 2 times FM max. Okay, whichever is maximum frequency that is available in your message signal. So which one of these two is maximum? 20 kilohertz. So 2 into 20, that is 40 kilohertz. Very simple. Okay, what is the carrier signal power? So carrier signal power is nothing but PC is equal to PC is equal to AC square by 2. So AC square, AC is 20, so 20 square by 2, that is 400 by 2, that is 200 watt. Very simple. Okay, what is the total power in this thing? So for calculating the total power we need mu, right? And mu1 and mu2 is given. So you guys know already mu t, the total mu will be how much? Mu1 square plus mu2 square. So that is going to come up as 0.36 plus 0.64. Why? Because 0.6 chi square is 0.36 and 0.8 chi square is 0.64. That is going to come up as 1. Okay, so isn't it very easy to calculate? PT is equal to PC into 1 plus mu square by 2, where mu will be used the total modulation index. Okay, so I have actually done it for you. So you can see mu t is 1 and bandwidth that we had calculated is 40 kilowatt, and PC we had calculated 200 watt. We can calculate PC will be sorry, PT will be PC into 1 plus mu t square by 2, so it will become 200 into 1 plus mu square by 2, so that will become 300. Why 300? This is actually going to be 200 multiplied by 2 1 are 2 plus 1 3 by 2. Okay, so this is 100, so 100 into 3 is 300 watt. Okay, now next question was what is the sideband power? So sideband power you know already. What is the total power? What is the carrier power? So from carrier power and total power we can calculate my sideband power, that is total power minus carrier power, which will be sideband powers. Okay, in amplitude modulation what is your upper sideband and lower sideband powers? So that will be half, total sideband power divided by 2 will be the powers available in upper as well as lower sidebands. Okay, so that will be 50 watt. Okay, or if you want this is the 50 watt that is available for lower sideband as well as upper sideband. Now the problem is this is not as simple as that. Why? because we had two message signals. So if two message signal is there, so in each one of them there will be one lower sideband and one upper sideband, isn't it? So I will find out what is my PUSB1. So you know already that USB 1 was, I mean PSB was how much? PC into mu square by 2. Okay, so PUSB will be how much? PC into mu square by 4. Okay, and PC was how much? AC square by 2 into mu square by 4, that is AC square into mu square by 8. Okay, so this is the like understanding. So I have utilized here AC square into mu square by 8. Okay, so for first message signal, okay, what is your USB, I mean upper sideband power? So I will utilize mu1. Okay, so that will be how much? AC square, that is 400 into 0.36 divided by 8, so that is going to give me 8 and 400 got cancelled, so it is going to give me 50. 50 into 0.36 is 18 watt. Okay, so 18 watt is the power available in USB 1. What about USB 2? So AC square into mu square by 8, mu 2 square by 8, that is 32 watt. So you can see total USB power was how much? 50 watt, right? As you can see from the previous, total USB power was how much? 50 watt, right? So USB 1 is 18 watt and USB 2 is, you don't have to calculate using this formula, you can calculate USB 2 is equal to total USB minus USB 1, that will be 32 watt. That is also another method to find out. Okay, similarly LSB 1 and LSB 2 can be equal to the same thing. Like what will be my PLSB 1, that will be 18 watt, and PLSB 2, that will be equal to PUSB 2, that is 32 watt. Okay, what is the efficiency? So efficiency I had told you mu square by 2 plus mu square. So here we will utilize the total modulation index. So total modulation index is 1. So 1 by 2 plus 1, that is 1 by 3, that is 33.33%. Or otherwise you can do one more thing. The sideband power divided by total power, that will be 100 divided by 300, that is 1 by 3, that is again 33.33%. Okay, so this is how we have solved very good questions. Two questions in like amplitude modulation that was asked in previous year GATE paper. So alright guys, thank you.